So thanks everyone for joining to our session, Validating the Edge, where bits meet beyond. We'll talk about an important topic when it comes to ensuring the solutions and products satisfy the needs, stability, security, and other types of needs. And maybe we can introduce ourselves first. Edu, you want to go?
Sure, yeah. So my name is Eduardo Mínguez. I'm a senior Edge container engineer at SUSE. I've been here for 1 year and a few months already. And you can find me on all those links if you're interested in know more about me.
Thanks, Edu. My name is Fatih Dermenci. I'm a QA engineer at Edge Unit, and I am the, I think, newest addition to the team. Like, I joined in April from Linux Foundation. I've been working in CI/CD testing and all the related areas for quite some time. And as I mentioned, today we will talk about the area that is actually pretty critical, like testing, validation, continuous integration, continuous delivery, and so on. And I personally consider these areas as competitive advantage because everyone talks about new technologies, Kubernetes this, or all these different features, cloud native technologies, and so on. But during one of the talks yesterday, I think Philip's talk, Keith Basil mentioned that you can have the best product ever, but if you can't get that product deployed to production, then it doesn't matter because you will not be able to deploy that product in production. No one will know about it. And that was about security topic, but in general, this area, testing, validation, security, and so on, it is so important that having capabilities and abilities to get the products and solutions to hands of customers become even more important moving forward. And that's why we start to talk about the technology transformation first, because last 10, 20 years, lots of things changed, which we all know, and how those things, the new technologies, new methodologies impact the surrounding areas such as delivery, testing, and validation. And from there, Edu will take us through the Edge Stack overview and then dive deep into Edge Stack validation, and we will finish our session by talking about some kind of future of stack validation and general CI/CD for Edge unit. So technology transformation, again, we all know what's been happening last 10, 20 years. If we go back to early 2000s, early 2010 and so on, virtualization, yes, it was there, but it wasn't widely available. It wasn't used by different industries and so on. And mid-2010s, 2014, 15, when Kubernetes was donated to Linux Foundation, all these microservice cloud native became kind of cool, new way of doing things, and leaving from monolith behind and moving to more disaggregated and microservice way of doing things. And some of the industries were leading this effort, but some other industries, they were a bit behind when it comes to technology transformation. And I pick some of the more traditional industries like telco, manufacturing, and so on. And those industries are also embracing the new technologies and new methodologies when it comes to building their products and solutions. I spent 16 years in telco industry. I worked for one of the vendors, and I was part of the transformation when it comes to mobile networks from 2G, 3G, 4G, and finally 5G. And I witnessed firsthand how the products were built early 2000s and how they are currently built from all those large monoliths into microservice container-based products. And while these new technologies, coming into new industries, different players are coming into play as well. Again, if I talk about telco industry, there are lots of large vendors out there and large operators out there, but there are new breed of companies coming into play as well, thanks to all these microservice and cloud native, applications, so they can provide very specialized products and solutions to their customers, and they can enter into market. And this makes these different industry sectors quite, challenging when it comes to continuous integration, continuous delivery, and continuous testing. So I just want to talk about telecommunications a bit further to talk about the changes that's been happening over a decade now. Like if we look at the right-hand side, everything was, purpose-built, specialized hardware, specialized software. We had this, proprietary hardware in the bottom. We had some platform on top of it, which is again proprietary, some orchestration framework, and there are physical network functions. And these are vertically integrated. And when you buy something, you buy the entire stack from one or two vendors because there is no disaggregation within the stack. But thanks to virtualization and later on cloud native, things started becoming virtualized. First, around 2014, I think HCI NFV released their first white paper around network functions virtualization. That started a conversation within the telco industry, and first set of virtual network functions started appearing, and the platform of choice for virtualized network functions was OpenStack those days, about 7, 8 years ago. And then cloud native happened, Kubernetes came into play, and things started becoming containerized. And from virtual network functions to cloud native network functions. And with that, you start seeing industry standard hardware like x86, ARM64 hardware in the bottom. You have industry standard platform. Linux became the platform for anything that can be, put on top of Linux. And then Kubernetes came into play as the standard orchestration framework. And then you would be able to bring in your cloud native network functions and virtual network functions easier than in the past, because you don't have to get the entire integrated stack, but you can, change things running in your production environment with the new versions faster than before. And if you look at how the delivery is done today, like there is a vendor, that vendor is developing new products, it's cloud native network function, it's been pushed to communication service providers environments using continuous delivery. And since everything is, kind of standardized, disaggregated, and using open source technologies, this made things happen faster. The new services were introduced faster, the new, products are introduced faster, bugs fixed faster, security issues fixed faster, and so on, because of this agility thanks to cloud native technologies as well as continuous integration, continuous delivery methodologies. But if you think some more, you might see that, okay, in the past there were one or two vendors. There weren't many, deliveries coming into communication service providers. They only had to deal with one or two vendors. But because of this disaggregation and openness, now the delivery ecosystem, continuous delivery ecosystem and continuous delivery methodologies, they are becoming some kind of outdated, because these paradigms have been around for 15, 20 years, and when they were first, came into play, the integration, delivery, testing, validation, the ecosystem wasn't this fragmented. Now, when we look at what's happening, again, a simple, diagram talking about a communication service provider, a mobile operator, for example. Now they are bringing products from multiple vendors, and this results in multi-vendor pipelines and multi-vendor validation capabilities and so on. And this increases the need to have a common approach into delivery, testing, and validation, so the products or new versions of existing products can be delivered in a streamlined manner. And as I mentioned in the beginning, I think this topic, software delivery, will become a competitive advantage, because if you are not able to deliver into a highly, fragmented, disaggregated environment, then you will not be able to take part in those, businesses. And here, maybe Edu can talk about HStack, because HStack, how it looks is pretty similar to my diagrams, but it has products highlighted in them.
All right, so thank you for the introduction. I'm going to talk about the SUSE HStack very briefly, because you have seen the keynote probably this morning, and there's been a ton of talks about what we are doing with the SUSE HStack, so I will try to be really brief. I'm not going to talk about the far edge, near edge, tiny edge, all that stuff. I'm just going to jump into some of the details. So from the management side of things, we like to divide, let's say, the edge stack into two different things. So on the right-hand side, you can see what we call the management stack. Basically, we leverage the capabilities of Rancher Prime to manage hundreds or thousands of clusters in the wild, and we use, of course, the capabilities that it includes, such as the GitOps engine, which is Fleet, and some other features that Rancher Prime has. And on the right-hand side, you can see the runtime stack, or what we call the edge clusters, where basically the components that you can see on the slide are the SliMicro as the base operating system. It fits perfectly into the picture because it brings all the SLES capabilities and features, security aspects, etc. But it's a lightweight operating system. It's immutable. It's ready for this cloud-native approach, and so on and so forth. And on top of SliMicro, we can deploy K3s or RKE2. We give customers the ability to choose between those two Kubernetes distributions that we ship. Then we, of course, provide security based on the new Vector product, and we can use the Longhorn in order to deploy or to provide access to the block storage. And then on top of that stack, the SUSE Edge stack is, of course, the container workloads that you customers and partners are using. So this is kind of a small introduction about the SUSE solution overview. And then those are the components that are part of the SUSE Edge stack. Starting from the bottom, you can see the operating system, as I mentioned, SliMicro, but some other important components that we use for onboarding and the logistics, such as Elemental, Metal 3 to manage the bare metal cluster, and the Edge Image Builder that builds the container, the operating system image with all the assets included in here. And on the orchestration layer, as I mentioned, RKE2, K3s, and sometime in the future we will include Podman as well. And for the platform itself, I included a lot of logos here that you can see. So for virtualization, we ship KubeVirt, Longhorn, New Vector, etc. We also ship Metal LB to provide a virtual IP or a load balancer capabilities in bare metal servers, and some other logos here from partners such as the NATs that provide the message bus, the Grafana, Linkerd, etc. With regards to the provision on SUSE Edge, we have three different scenarios, let's say. So but in all of them, we would like to provide the zero-touch provisioning experience, meaning that you don't need basically to do things manually. And we are thinking on three different, as I mentioned, scenarios. So the first one will be the direct network provisioning when, such as, for example, a telco rack where they are bare metal servers. This is known hardware, and it has out-of-band access, so we can connect to them directly. And we use Metal 3 and Cluster API to deploy the operating system, the Kubernetes cluster, and the workloads on top. The phone home network provision, this is more intended for tiny edge, let's say, where you imagine those those hosts in the factory, and then you ship it to the real world. And then when they are powered on, they phone home in order to be customized when they are shipped. So in order to do that, we use the Elemental, which basically manages all that phone home, going back and customize the operating system and Kubernetes cluster and deploy the workloads on top. And we have the image-based provisioning, which is based on the Edge Image Builder tool that we created, where basically you can create an image on a USB stick or an ISO or a CD with a prescribed configuration that will include everything required to run your workload on your cluster, including the operating system, SliMicro, RK2, K3s, all the other Edge components, Longhorn, etc., and your workload included. So you just need to go to your, to the remote location, plug the USB, turn it on, and it will install everything. This was just a brief introduction to the SUSE Edge stack, and one of the things that we are doing for Edge is we are building this kind of framework that we call stack validation. Essentially, we would like to provide customers and partners validated designs. What does it mean is that we at Edge, we cover a lot of scenarios like tiny Edge, single node in a remote location with just the operating system, maybe K3s and a couple of two workloads on top, or big cluster in a telco space with bare metal hosts, different workloads that needs to have, 20 servers or something like that. So we want to do some reference designs, prescribed design, where we define the different versions that we suggest or provide to customers, and not only from the operating system on Kubernetes, but also the other Edge stack components as well. And we would like to provide you the details on how to implement those, because we already tested them internally, and we are sure that this particular version with this particular other version works as it should. So that is what the validated designs are. And in order to validate that, we built the stack validation. Stack validation is basically the implementation of the validated designs and the testing that happens on that validated design. We use it to verify, as I mentioned, those validated designs. We build it in the open source, open standard mindset. We are currently it's not currently open source yet, but there's plans to make it available. It's driven, as I mentioned, for different use cases and market segments. So, as I mentioned before, small cluster with just a single node with just a couple of workloads, or full-fledged HA cluster on bare metal with AI things running on top. One thing that we are trying to push is we would like, or we are actually publishing the results of these tests or this validation, because we want to offer customers and partners the reliability that we already tested it, and here's the results of that testing, in order to drive confidence and trust in our customer base. So the use cases that we are actually planning to implement, or some of them are already implemented on the stack validation, are those. Of course, the first one would be the deployment of the thing, because if we want to test things on top of that, such as the chaos testing or high availability, we need to have the deployment first. Then we are actually implementing hardening. There's a few things that we do in order to harden the stack, starting from the operating system with enabling FIPS, And for RK2, we can enable CIS features. We have upgrade testing, chaos testing, high availability testing, performance testing, and day-to scenarios like what if I have a backup and my node is dead, how I'm going to restore it, will it behave as it should again, etc., etc. The major focus areas right now for stack validation are those 3 boxes. The blue one talks about the provisioning. As I mentioned before, we need to be able to automate the provision of everything or all the use cases. That includes multiple components, not just for the operating system and the Kubernetes layer, but all the things that goes on top, and in order to support different use cases. We focus as well on the testing side of things, where we would like to validate those different scenarios from single node, HA, different components on top that makes those use cases. And we are focused as well on the visualization side of things. When we run the automation, we run the test, and we publish those tests and those results in the public. We are starting on this journey right now, so we will improve in that sense, and we would like to offer some dashboards that will show how the thing evolved since the beginning, etc. With regards to the framework environment, we would like to do it really flexible and composable, because again, the use cases that we want to cover are really different. So there's no one size fits all, but instead different things that we need to plug, let's say, in order to do that. So we use also different tools for that framework. Starting with Libvirt, we can deploy or we can create VMs, or we can provision the clusters on top of bare metal hosts using Redfish. We use Ansible to orchestrate all the automation steps that happens. We are pipeline based, and we use right now GitLab pipelines to manage and trigger the pipeline that builds the clusters and run the tests. We use some Python code as a glue code for some stuff. And this logo here is the testing framework that we use, that it's called BATS, that I will talk about in a few minutes. We have this flexibility in mind since the beginning. As I mentioned, we cover a lot of use cases, so we wanted the automation code and the framework to be really flexible. We support deploying clusters either on virtual machines or bare metal. The virtual machines are created by the automation as well. You just need to point it to a hypervisor, and then it will do what it's required to run the virtual machines. And we follow the same approach both for virtual machines and bare metal. We use Redfish to power on the machine, to add or insert the virtual CD, etc. We use the one thing called the Sushi emulator that simulates a Redfish API for the VMs. We use right now SliMicro self-install, and we customize it using Edge Image Builder. So the automation uses Edge Image Builder to build what will be installed on the machine itself. We can choose to deploy either K3s or RK2 with different use cases. We can choose to deploy just a single node, an all-in-one cluster, control plane, agent. If we want to enable CLinux, Multus, we can choose the CNI, etc. And we can also add extra manifests that will be deployed when the cluster is up, or we can apply manifests even after the cluster is running. For HA scenarios, we use on the Edge stack, we embed MetalLV for the API endpoint, so it's already included when you deploy a 3-node cluster under the hood. Even you don't need to know the details, but it's already embedded. And we can choose the different edge components that we want to deploy on top, like Metal LB, Metal 3, Rancher, KubeVirt, Longhorn, NuVector, all the Rancher UI plugins that we ship, etc. And then we can perform operating system customization as well, like disabling some services, installing packages, enable or disable FIPS, etc. So all that stuff can be customized. You can choose for example, the RK2 version that you want to run for that particular execution. You can choose which edge component and which version do you want to use quite easily. There's no need to, so they're not hard-coded values, let's say. And as I mentioned, everything is configurable and flexible. We can deploy just a small VM with the operating system, or we can deploy a full-blown HA cluster with all the components and custom versions. The provisioning scenarios that we are covering so far, in fact, this is outdated. Last week, there's a few others that has been included. And when I mean provisioning scenarios, those are the ones that are running daily, on daily basis, and continuously. We have, for example, the single node RK2 cluster plus Rancher plus KubeVirt and the KubeVirt dashboard, and we enable FIPS on the operating system level. We cover also HA scenarios with RK2 plus Metal 3, Rancher, and NuVector. So what we call the management cluster on the left-hand side on one of the first slides. Then we deploy a real bare metal cluster using Metal LB. So we deploy both the management cluster and the edge cluster using this framework. We do the same for Elemental. We deploy an HA RK2 cluster. We deploy the Elemental bits on top. And then we provision a bare metal cluster with FIPS enable using those Elemental manifests and stuff. And finally, this last one is a single node RK2 cluster, and we deploy Metal 3 on top. And then we deploy an HA edge cluster on bare metal. So we have 4 bare metal servers that are provisioned on daily basis with this framework in order to prove that everything is still working. So the question is, how are we testing this? How are we validating those designs? Which tools are we using? It was a little bit tricky to find a tool that covers all those use cases, because we just don't want to have tests in the sense of testing this feature or this other, but we want to cover all that stuff. Like, we want to test kind of infrastructure provisioning. We want to test things on Kubernetes or at Kubernetes level, and we have complex use cases that we want to tackle, such as cluster upgrades, replace nodes, backup and restore, disaster recovery. So essentially, the 2 scenarios. So this is the kind of test that we are running right now. Those are, in fact, 2 disruptive tests, let's say, where the first one, for example, verify that the nodes are up, and then it deploys a small application that writes continuously into a Longhorn volume, and while the application is running, it kills the node where the application is not running, in order to verify that the application can still write. And even though there's no 3 replicas of that volume, but instead 2, and then it waits for the node to be up and verifies that it can still be writing. And this one here does something similar. In this case, it kills the node where the application is running, and then when the node comes back, it checks that it can still be working. So Longhorn was working as it should. The output is the typical or classic JUnit output, and we are using, as I mentioned, the batch framework to run these kind of tests. This is a screenshot of the stack validation public results. You can see on the left-hand side the list of executions of the framework. And on the right-hand side, you can see the details. So when you click on one of them, you can see more details about the execution, including the when it started, the time that it took to run that test or that execution, some details on the job, the variables, the parameters, the compute. And in this link here, we have the public URL. Maybe I can show you. So you can see here the results, right? As I mentioned, on the left-hand side, you can see the list of executions, and on the right-hand side, you can see more details. So you can see, in fact, we can make it bigger. You can see the jobs. If you click on the details icon, you would see the logs of the provision. This is an Ansible execution. You can see the summary at the bottom. You can see the variables that we use to deploy this scenario. Like, for example, the default versions, we use Edge 3.0. We didn't run the disruptive test for this one. This is the component that we run for the Edge stack, the Edge Image Builder image that we use, etc. And if we go here, you can see the Edge Image Builder configuration file that was built for that, with the details about the nodes, the operating system customization, etc. You can see here also the Kubernetes customization, the Helm values that we use, the Kubernetes manifest that were injected in the cluster itself, even custom files or custom script that we can inject. And you can see here also more details about the environment or the compute in this case. You can see the specs of the VMs that were created, the Edge Image Builder network config for each one. And finally, you can see here on the first tab the test summary. So you can see that it ran 58 of 62 tests. It skipped 4 tests. And you can see the details of the test here. For example, this one are the prerequisites kind of tests, the RK2 test, the rancher test, etc. And if you click on some of them, you can see more details. If they pass, they don't show anything. They basically say that they passed, and you can see the time that it took for that test to pass. And you can see back here that we have the apply elemental manifest. We run upgrade tests as well. So in this case, we upgrade the cluster that was already available, and then we run tests against that upgrade test in order to verify that everything is still working. Okay, and going back to you.
Thanks, Edu, for talking about the details. So we have a solid foundation in place when it comes to getting things provisioned, deployed, and tested. And as I said, like, I am the newest addition to the team, and when I joined, I was kind of quite impressed and happy when it comes to people's take on testing, validation, CI/CD. This seriously, but what impressed me a lot is publishing the results publicly. That is awesome, because like you can literally see everything we are doing in our environment on the internet. You can go and you will see like 5 runs failed after each other, because we are running those things through our CI as well. Sometimes we introduce bugs and those things are displayed directly there. So it's like full transparency, openness that is key for ensuring that we build trust and confidence with our partners and customers. As I said, we have a solid foundation, and for future, again, this is kind of speculation and dreaming at the same time. We want to increase the scale. Like currently, we are running things in our unit, but we want to go to the left, earlier sides of things like upstream communities, because all these things are coming from upstream, Kubernetes, Longhorn, or other SUSE business units. We want to extend our validation efforts to the left-hand side, so we can proactively test things before they hit our environment, so we know if things work or not, and we can bump versions accordingly. In the middle, our current stack validation, and we want to go further right to our customers. We want to run some kind of distributed validation with our customers, extending our pipelines, and perhaps exchanging the test results with each other, because what might work in our environment might not work in their environment, and we need to find why it didn't work as expected because it worked in our environment. And that is key for us to, get things much faster and with higher quality, and that requires us to increase our scale and hooking into these different systems and using, a more, scalable solution for our validation efforts. Again, testing is never-ending activity. We have lots of test cases, but we want to increase our test coverage. And it's not just about us writing the test case. You will look into reusing some test cases and frameworks from other units within other open source communities and so on, and make them part of our validation framework, respectively, and if they are applicable. Obviously, we need to increase the automation. Now, again, everything that you see on that page, the stack validation results, everything is done automatically. We don't, go and change things. When the pipeline starts running, it does everything automatically. But we want to do even more automation to, support our efforts to scale what we are doing. And the visualization, it looks awesome, and it addresses certain needs and use case. We need to bring up additional visualization capabilities, perhaps, giving different look of the same data based on the purpose. Because for some of our customers or some of our colleagues, this visualization is not detailed enough. We need to find out those needs and bring additional visualization capabilities. And perhaps most important one is collaboration. Again, we depend on open source, we depend on other units within SUSE, we work with partners, we work with customers. And obviously, a lot of collaboration happened while bringing up stack validation, the current state. But we need to continue with that collaboration effort to make sure that we all can, gain something by, contributing these efforts. So, where you can find us, we have a landing page on SUSE.com, and you can scan the QR codes that they will take you there. So you can look at landing page on SUSE.com to see the solution. We have our documentation available on SUSE.com as well. I think Monday our first Z stream release was published, so you will have 301 release documentation available there. On GitHub, we have SUSE Edge organization. All our repos, like the Edge Image Builder and some other related repos, are available there. And as Edu said, the stack validation framework and test case, they are not currently open source. But I think, since we are publishing the results, everything is visible there. I think we will, go towards that direction to open source those things as well. And finally, we are pretty active in various communities like Linux Foundation Networking, Silva, CD Foundation, and as you have seen this morning, if you were there, Keith basically announced SUSE's participation in Margo community. Because again, it's the same thing he said, if you want to go further, we need to run together, and it is key for us to take part in the communities, not just as a consumer. Be contributor, be good citizens to communities, contribute what we can do best, and take what is happening in the communities into our environment to make our efforts even more successful. And yeah, we are on time. We have about 10 minutes for questions.
So thank you for the presentation, amazing. I have a question. Can customers benefit from this? Is it just to see the tests that the tools you use are working well together, or can a customer run this against their existing environment and validate their environment, like a production environment?
Maybe I can answer because I have an anecdote. Just before we start talking about this, we started this session, I was telling Edu that I was able to build the tests in its own container image, so we can pass them to anyone who wants them. So we are working on splitting different pieces of the framework, so tests can be independent. You can take that image, or you can even look at the repo when we open source it, for example, and run it in your environment. And you should see it just works because you only depend on kubeconfig, kubectl, and that's it. And you run it against environment. But that's what I think. Maybe Edu.
Yeah,
wanted to-
I mean, we build that, as I mentioned, in order to validate those validated designs, let's say. But yeah, we are thinking about why don't we make this publicly available, especially, for example, the tests, so anyone can benefit of running the same test that we are running to validate that in the public. And we as I mentioned, we build it to give us confidence on those validated designs, that this particular version works as it should with this particular version and this other. So yeah, maybe in fact we can collaborate on running those tests wherever you need.
Yeah, and like we will publish those images probably on Open Build service, so
Yeah.
you should be able to pull Podman pull and just run the test. But we are not there yet. But
Yeah.
this morning we were talking about that, like how we can share the framework as well, not just the results. Yes, we are done. Thanks
Okay.
a lot for
Thank you
joining
so much.
today. Thank you very much.